Hello and once again welcome to Pankaj's Echelon tutorial. In this session we are going to do one numerical connected to the topic called force of electrostatic force between 2-point charges. Now in the last video we discussed that force between any two charges, point charges, given by this formula K times Q1 Q2 divided by this was the formula that we studied. The theoretical formula, the force between any two charges. If the charges are like charges, then the force will be of repulsion. If the charges are like charges, opposite charges, then attraction. Now K will depend upon the medium. Let us do the numerical based on this. Now numerical says that say there are two charges, Q1 and Q2, and the distance between these two charges is say centimeter. Okay, distance D is equal to 3 centimeter. The charge Q1 is positive, charge Q2 is also positive. Values are Q1 is 2 microcoulomb, Q2 is 8 microcoulomb. So with this as the situation, you have to answer these questions. A, calculate the force exerted on each charge in vacuum. Okay. B is calculate the force exerted on each charge, okay, in water. And the C part, the question is, okay, in the case of B, it is given that the permittivity of water is 80 times more than that of vacuum. Now C part of the question is, if charge on Q1 is increased to 4 microcoulomb, okay, instead of 2 it has been increased to 4 microcoulomb. Now calculate the force between them. Okay, so basically we are going to make use of this particular formula to answer all these three questions A, B and C. Let us go for the solution. The solution for A part is, using this formula, force is equal to K times 1 whole divided by R square. Now we know the values of K in vacuum. Okay, so actually in the data sheet Ibdp you will get the value for K in case of vacuum, but I would advise you to at least by heart value of K for vacuum and water. K for vacuum value is 9 multiplied by 10 raised to into Q1 value is 2 microcoulomb. In coulombs it will be 2 into 10 raised to minus 6, and Q2 is 8 microcoulomb, so that I can write 8 into 10 raised to minus microcoulomb. I have converted into coulomb. Whole thing divided by r is the distance between the charges. So they are separated by a distance of 3 centimeter, but the distance has to be in meter. So it is 0.03. That's squared. And when you work out this, you should get 9 to the 18 into 8. Okay, let me do that. So you'll get 16 times 10 to the power of 4 times 10 to the power of, this works out to 16 10 equal to 106. And because this is force, so the it will be Newton. The A part of the question ka answer you got. Force exerted between the two charges will be 160 Newton. The force will be repulsive force because both the charges are positive. So this was in the case of vacuum. Let us go for the B part of the question. B part of the question says that calculate the force exerted on each charge in water. Now instead of vacuum, now the case is that of a water. Okay. Now there are two things. Either you take the K value of water, that all you know from the Ibdp data sheet, okay, formula sheet, or you can use this particular information which you want to use. What information is? The permittivity of water 80 times more than that of vacuum. So here he is talking about permittivity. I will change this formula of force F equal to, now instead of K, I am going to write 1 upon I, epsilon is permitted. Okay, into 1 divided by, right? Now, I'm not going to put the value, I'm not bothered about all these things. Okay, I know one thing, that this epsilon, in the case of water, is 80 times more. Okay. So, F, the case of water, will be 1 upon, this epsilon will be 80 times more. So, it will be 80 into 4 pi down into Q1 on. Now, this value, 1 upon 4 pi into Q1 Q2 on R square, you have already calculated and you got it as 160 Newton. So here, all you have to do is this 160 Newton, you will have to divide by this 80. Okay, because now it is in the case of water. This was in the case of vacuum, isn't it? So this will give you 2 Newton. The answer for the B part of the question is, in water, since the permittivity is increased by 80 times, therefore the force will be decreased accordingly, proportionally. So how much it will decrease? So you have to do 160 divided by 80, get 2 Newton. The force between the two charges will be repulsive force because both are positive charge, and now the magnitude of the force will be 2 Newton, be decreased. Okay. C part of the question, let us answer this. If the charge Q1 is increased to 4, okay, now what happens? Here also, we are going to use the same way. Okay, F is equal to K 1 Q2 on R square. The case of vacuum, okay, we got the value as 160 Newton. Isn't it? Now, in this case, the Q1 was 2 microcoulomb, was 8 coulomb, and your R was 0.03 meters, right? Now, what the changes taken place is the F, you have to find out in the new scenario, again you have to find out vacuum. So the new scenario is your Q1 has been increased to 4. So your K will remain same. Only this Q1 will become, instead of 2, it will become 4. So instead of, here I'll introduce a factor of, other things is going to remain same. Right? Now, this value we got as 160 Newton. Okay. So here, in this case, okay, when, this is the case when One is 4 microcoulomb, isn't it? From 2, we have increased it to 4. So this particular value, okay, you have a 2. Now this 2 I will take, write it. Let me write this here. So it will be 2 times this value, we had already got it as. So when Q1 is increased to 4 microcoulomb, your new force will be equal to 320. 116 to 2 is 300. So these are your answers. So answer for the A part of the was 160 Newton. Answer for the B part of the question was 2 Newton. So for the C part of the question is 300. This was the numerical, which was based on nothing but the force of electrostatic force, either repulsion or attraction charges. Okay, that's all for today. Bye.